In this video, we will learn how to graph using what is called the intercept method. Before we look at examples, let's define what intercepts are. First, an x-intercept of the graph of an equation is a point where the graph intercepts the x-axis. Similarly, a y-intercept of the graph of an equation is a point where the graph intercepts the y-axis. So let's take a look at what x and y intercepts mean graphically. Take a look at the line graph provided on the right. In the previous slide, we said an x-intercept of the graph of an equation is a point where the graph intercepts the x-axis. Looking at this graph, we notice the line intercepts the x-axis here at -5. So there are two ways we can express this. We can say that the x-intercept occurs at -5. The more common way to express the intercepts are as an ordered pair. So as an ordered pair, this would be -5, 0. Remember, to get to this point, as we move from the origin, we would move to the left 5 spaces first, and then up and down 0. Similarly, in the previous slide, we said the y-intercept of the graph of an equation is a point where the graph intercepts the y-axis. So looking at this line, we see that the line intercepts the y-axis here at 9. So in a similar fashion, we can say the y-intercept occurs at 9, but the more common way to express this would be also as an ordered pair. So this time, the ordered pair would be 0 first, then 9. Again, as we move from the origin, we don't move left and right any spaces, so the first number would be 0, and then the second number, since we moved up 9 spaces, would be +9. So we have an x-intercept of -5, 0, and a y-intercept of 0, 9. In the two examples that follow this slide, we will be given an equation and asked to determine the intercepts based on the equation. So to set those problems up, let's take a look at points along the x and the y-axis to see if we notice anything in common. So for example, looking first at the x-axis, what would this point here be as an ordered pair? Now remembering we move left and right first, then up and down, as an ordered pair that would represent the point 6, 0. Let's grab another point along the x-axis. Let's grab this one all the way on the left. As an ordered pair, that would represent the point -10, 0. So any point along the x-axis will have a value of 0 for y. Now the opposite is true for points along the y-axis. Let's grab a couple of points and look at their ordered pairs. So for example, if I place a point at 8 along the y-axis, as an ordered pair, since we're moving left and right first, and then up and down, as an ordered pair this would represent the point 0, 8. Let's grab another. Let's put a point down here at -3. As an ordered pair, that would represent the point 0, -3. So if we notice, any point along the y-axis will have 0 as its value for x. So that's going to be our strategy in the next two slides, where we're given an equation and asked to determine the intercepts based on the equation. So to determine any x-intercept, we will use this strategy of plugging in 0 for y. And then similarly, when given an equation and asked to determine any y-intercepts, we will substitute the value of 0 for x. So for our first example, let's look at the equation 6x minus 16y equals 48. Now remember, we said to find any x-intercepts, we use the value of 0 for y. So for x-intercepts, we will substitute 0 for y into the equation. So based on our equation, that's going to look like 6x minus 16 times 0 equals 48. Now 16 times 0 is 0. So we're left really with just 6x equals 48. And to solve for x, since we have 6 times x, we divide both sides by 6, and we get x equals 8. So this means our x-intercept is at 8 along the x-axis. Now as a ordered pair, we would express this as x comma y, or 8 comma 0. So our x-intercept is located at 8 comma 0. So let's go ahead and put that point on the graph now. And then we repeat a similar process to find the y-intercept. So to determine the y-intercept, this time we're using 0 in place of x. So based on our equation, that's going to look like 6 times 0 minus 16y equals 48. 6 times 0 is 0, so we're really left here with negative 16y equals 48. And to solve for y, we divide both sides by negative 16. 48 divided by negative 16 would be negative 3. So this means the graph of this line intercepts the y-axis at negative 3. Now we can express this as an ordered pair as well. X comma y, in this case, would represent 0 comma negative 3. So if we come over to our graph and plot the point 0, negative 3, we are at negative 3 along the y-axis, and then the only thing left to do is connect these 2 points, and we have the graph of our line. Now this is just an alternate method to the method we discussed first. The earlier method we sometimes refer to as the plotting points method. And for that method, we chose random numbers, and we plugged random numbers in for the value of x or y, and then found the other value. So this is just an alternate method that you might find a little faster. So let's take a look at another example. In this last example, we will find the intercepts of y equals 2x minus 5, and then use that information to sketch the graph. So for the x-intercept, we've established that we use 0 for y. Based on our equation, that will look like 0 equals 2x minus 5. And then solving for x, we add 5 to both sides. So then we have 5 equals 2x. And isolating the x, we divide by 2 in the next step. And then that leaves us with 5 halves. Now with some quick division, we know we can write 5 halves as 2 and 1 half. And that might help with plotting the point. So our ordered pair in the form x comma y here would be 2 and 1 half comma 0. Next we will determine the y-intercept, and we've established here that we will use 0 for x. So based on our equation, that looks like y equals 2 times 0 minus 5. And then 2 times 0 is 0, so that leaves us with negative 5 for y, and writing that as an ordered pair would be in the form 0, comma, negative 5. And then the final step is plotting these 2 points and sketching the line. So for the x-intercept, that's 2 1/2, comma, 0. So that point is halfway between 2 and 3. And then the y-intercept is at 0, negative 5. So at negative 5 along the y-axis. And then connecting these 2 points gives us this line. And now we've completed that problem.